Good evening, everyone. It'd probably be helpful if I moved the mic correctly. And I messed that up already. I'm already off to a good start this evening. I can't believe I forgot to move the mic. I'm really doing good. There is a lot to talk about this evening. Let's see. Where do we want to start? Well, the models certainly have gotten a bit colder, and that is certainly interesting. And there has been a growing development of stronger support for high latitude blocking and evolution there. Just a note, guys, I know some people are asking for a private chat in the middle of this video chat, and I will decline that because there's just too much going on right now to do a private chat, obviously. So where was I? Okay. Where do we begin? There's so much to talk about. So I guess let's start with what is happening in the atmosphere right now, because I think if we understand what is evolving right now, then I think you'll understand what the model guidance is trying to do, and why I'm still warning, don't trust the details just yet. I know that the models came out in 12Z, awfully snowy for many locations, and I get the excitement. God knows, after it's been very, very dead. Those of you away from the I-95 corridor, north and west of the I-95 corridor, probably could have a little bit more excitement than those on the coast. But I will tell you this. This is going to be a very interesting and challenging weather pattern to forecast for from now all the way through February. So why am I saying that? Well, instead of listening to me ramble, let's take a look at some of the observations. Now, what do we know? We know that the tropical forcing is definitely changing as we speak. The MJO factor is still in a cold phase, now moving from neutral, heading towards 1, 2, and 3. So your cold phases when it comes to the MJO is 8, 1, 2, and 3 in this type of weather pattern. But notice the MJO is still relatively weak here. So that tropical forcing, it's not that impressive, but it doesn't counter any potential for a colder weather pattern developing or countering the development of high latitude blocking. If the MJO was moving into phases 4, 5, and 6, then that would be a bad signal for you snow lovers out there. So we have that. Then we have what's going on with La Nina. This annoying feature that has been around for 3 years in various forms is finally weakening. And there are some signs in the subsurface, and I discussed this in the long range thoughts yesterday. There are some signs of an El Nino starting to develop in the subsurface. We have a long way to go until we get to that point. But there are signs for the first time in roughly 3 years of potential of that process starting. So we know that La Nina is weakening, and we know that the subsurface, let's see here. Here we are, is moderating quickly. And you can see it very nicely here, how that trend is evolving. Now, what I am keeping an eye on is this feature here expanding and growing. And it's been doing so for the past couple of weeks. And we're starting to see that development starting to take shape. So what does this tell us? Okay, so the tropical forcing, the same tropical forcing that really produced a very unusual jet streaks, especially during a La Nina year, slamming into the west coast, producing this mild pattern and making many people very nervous about the idea of any type of snowfall in the northern Mid-Atlantic. That support is dead. And we can see that very nicely here. Over the Pacific, We're seeing more support for a trough and below normal heights around Asia, and that translates to below normal heights around the Aleutians and building heights along the west coast. And the pattern is gradually changing. So what is the primary forcing parameters in our pattern? Okay, so we know we have some influence from La Nina, but we also are starting to see influences in the stratosphere. And what is very interesting is to see, here we are, this building warmth over the past couple of weeks that is growing steadily. This is the start of our stratospheric evolution. The stretching of the polar vortex is happening right now. In fact, let me refresh this. And you can see in the observations right now, 50 millibars, and this is under European guidance, it's here. It's being stretched. It's being torted and altered, and that's allowing for a developing weather pattern that would support a trough in the east. Typically, when you have a stretched polar vortex, that leads to a support for below normal heights over the eastern United States in some form, and also introduces the higher potential for high latitude blocking over the Arctic. And so we're starting to see that showing up in the model guidance very nicely, and weakening as well of the polar vortex. And we're also seeing that in the data here. This is from the GFS. This is a three-dimensional look of the polar vortex, and as you can see, it does not look very healthy. Okay, it's getting beaten up, it's getting pulled and taunted and just ripped apart. And you can see in the time series here, let's see here, isotropic, yeah. You can see the changes going on in the tropospheric, in the stratospheric level, and starting to influence the troposphere. So what I'm showing you here is some of the more in-depth data here that we look for. Something that you might be a little bit more used to seeing. You're seeing in the ensembles that stretching and weakening. Look how it's trying to split. But also notice there's a lot of volatility here. There's a lot of noise going on here in the forecast, which tells me that we're seeing a lot of different lifting parameters that are starting to interrupt and disrupt the circulation of this polar vortex. And of course, we can look at the EP flux, which I've been talking about for weeks on end. Remember, I said back in the fall that the influence of a volcano was going to alter different factors in our weather pattern. Okay? That this would not lead to a traditional La Nina, and that certainly has been the case with that jet streak, that it would lead to some potential for high latitude blocking that supports the feedback process for winter storms. Okay, so remember that. Now we're seeing that becoming even stronger of an influence. You can see when you get features like this showing up, and you can even go to 7 days out. Okay, this is 7 days out now. Now, not any widespread, or should I say long-ranged 15, 20 days out. This is 7 days out. Strong influence of this disruption, this transport from the mid-latitudes of the troposphere to the higher latitudes of the stratosphere. You're seeing that take shape right now. You can even go to 0 hours, the current observations, and so you can see that already taking shape. So what I'm showing you guys is that these are the observations. This is the evolution right now. Heat flux is also looking very impressive. Plenty of warm air being transported into the stratosphere. And what that leads to is this depiction. where this is a stretching signature, which would signify the pattern change evolving. And this is the first time in the European guidance where this is a major stratospheric warming event. Now, there is some debate as to whether or not we see the winds reverse at 10 millibars. That's kind of debatable. But certainly you have enough of a warming in the stratosphere to support a major displacement. And that is what we're starting to see for the first time here on the European guidance. We've been seeing this repeatedly on the GFS for some time. So, I guess you could say this is a win for the GFS in terms of this forecast actually verifying at the stratospheric level. So what does this mean? Why is this important? This signal is very important because what happens is that you can't have your polar vortex consolidate into a strong circle. Remember a couple of weeks ago, literally 10 days ago, you had the polar vortex almost like a donut, okay? So you have the donut here, right? Here's your cap. This is your polar vortex, and it's spinning really fast. And what happens is that all your cold air around this vortex cannot escape down towards the mid-levels. So what happens instead is that you create a thermal gradient and you enhance the jet streak in the polar jet stream, which happens to be what happened in the Pacific. So what happens is that the mid-latitudes below the polar vortex or south of the polar vortex is flooded with Pacific air. Now what we have is this circulation being disrupted. So now what you can have is your cold air being able to be introduced back into the mid-latitudes, and your Arctic air is able to be introduced into the mid-latitudes. And your Siberian air, well, that has the potential of crossing over into North America. And when you have temperatures in Siberia around minus 50 degrees Fahrenheit, that's pretty cold. And that type of cold air is heading towards North America. How exactly that evolves, still working on that. So what does this look like in the 500 millibar pattern? Now, I've been hearing a lot of interesting thoughts about, well, La Nina's pattern is going to lead to a southeast ridge. And it is an understandable scenario here. But let's discuss what that really means. First of all, understand this. The disruption of the polar vortex is going to lead to displacement of a typical La Nina pattern, but that does not mean the southeast ridge disappears. So in this solution right here, which I'm sure many people are looking at, and probably the GFS, they might be looking at that feature as well. What does this mean when you look at this? Well, you have to separate the jet streams here. Because you have the polar jet stream and Arctic jet stream around this ridge diving into Western Canada and heading towards the East Coast. So you have your cold air here. You have a signal of some sort of negative NAO here with below normal heights around 50 north, 50 west. You have a signal for a trough, so obviously a negative PNA. And that should be alarm bells for all you snow lovers out there normally, right? Understandably. But if you have an Arctic air mass sitting in here, and then you have this scenario here, this trough here, what you have then is cold air bleeding across the Great Lakes, and you set up this thermal gradient. So what you end up with is a storm track where you have a split pattern. You have the polar short waves diving south around this ridge through Western Canada towards the plains and towards the East Coast. And you have short waves in the subtropical jet stream moving into the West Coast, cutting under this ridge and heading towards the Mississippi River Valley and Tennessee River Valley. And where those short waves interact, that's where you get your storms. Now, what catches my attention, and what should catch yours, is this feature right here. This signal here tells me that if you have a 50-50 upper level low or trough, that's a 50 north, 50 west. If you have that set up here, that leads to strong surface high pressure here and a storm track towards the Delmarva Peninsula. If you have that upper level low up here in that scenario, in individual storms, that opens up the potential for low pressure systems to interact a little bit faster and able to cut up towards, let's say, the Hudson River Valley, leading to major snowfall for the interior, the Poconos, Catskills, western New York, and rain along the coast. Okay, so the question as we move into February is, what type of interaction are we dealing with here? And this feature here will regulate just how much influence the Southeast Ridge has. So anyone who might be saying or saying on social media, well, the Southeast Ridge is going to dominate, that's a declarative statement that I would not feel confident in saying. The Southeast Ridge will have the potential to become a stronger influence in this weather pattern if other factors are displaced. But if not, then that statement would basically fall apart. And then we go back to the feedback pattern, which brings us back to our current pattern right here. So, first of all, I want to show you, let's say this is 15 days out. Now, again, you don't want to take this verbatim, but here is your Arctic air, which is very impressive. That cold air bleeds, and then you get this near normal temperature regime here. And you get a nice thermal gradient set up. Ladies and gentlemen, this is your storm track. And why do you see this signal showing up? Well, remember, this is an ensemble blend, which is why I always say do not take this stuff verbatim. What does this blend mean? Well, different models are taking different storm tracks here, and some of them take them up towards the Great Lakes, some of them take to the south, and so what you end up with is cold solutions and warm solutions. You average them together, and you end up with this near normal signal here showing up. This is a stormy signal to me. This is where you do not take this verbatim and say, well, that means we put this number down and move about our day. What it tells me is caution, volatility is very high because you're going to have plenty of cold air to tap into in this scenario, depending on the interaction of the storms. So that takes us to our current pattern. And I'm sure everyone started to see this scenario here setting up for Sunday night into Monday and get very excited about the prospect for snow, especially in the interior. Coastal plain, not so much. Why is that the case? Well, in this scenario, you have a polar jet stream shortwave interacting with a disturbance in the subtropical jet stream, and the timing is such that the mid-level, upper-level low that you see right here, let me zoom in on this, is developing late. When you have a storm track of the 850 millibar low over you or to the west of you, that's a warm solution. That's rain. Unless you're in the middle of an Arctic air mass, which we are not. This also means that to the north and west of this upper level low, those of you in the Poconos, northeastern Pennsylvania, heck, even portions of south central Pennsylvania in this setup, are open up to the potential for some pretty significant snowfall in this scenario. But the key here is the timing of this interaction. But let's just say that the model guidance is 100% accurate in this solution, this depiction, and you end up with snow over the interior, rain on the coast. Why is this storm so important? Well, let's zoom out a little bit and go to 500 millibars. Now you see this feature right here? This sets up your next storm. This forces your next storm to be further south and colder because this feature is starting to set up the block already. And there you have it. Just strong enough to force this feature to focus its strongest lifting towards the coast. And as a result, your 850 millibar low is further east, which leads to a colder solution. What does this mean? This means that the previous storm ahead of you is going to have a significant impact on the next storm. And that feedback process leads to a tremendous amount of error in the forecast guidance because you can't get an accurate depiction of the upcoming pattern until you get the first storm out of the way. And then you see the influence of that first storm, and then that leads into a better forecast for the second storm. Then the second storm that follows in, that we'd be keeping an eye on right here, is influenced by the storm that's moving through in the middle of next week. And then your next storm back here becomes influenced by this shortwave here. So feedback after feedback after feedback, the model guidance is going to be playing catch up as a result. Does this mean that your backyard will see significant snowfall? I have no idea, and neither does anyone else. That's just the truth, and that's why I don't post snow maps out 7 days or 10 days in this scenario, really any scenario, but especially a scenario like this where you have the potential here of shifting to a much colder solution with each run. The setup for Sunday night, I don't think it has that potential of getting much colder than what we're seeing. Maybe slightly colder for, let's say, northwestern New Jersey, maybe some more snowfall there than what's being depicted right now. But the reason why is because I don't really have the high latitude blocking, and we'll go back to this feature back here. This storm has no blocking 5 days out to force the storm track and the development 850 millibar low further east. You'd have to basically thread the needle in this scenario because I don't have anything to slow down these features. See this? This right here is a bad signal for snowfall on the East Coast. Better potential for snowfall over the interior. But this solution, this signal, well, that's a different story. This slows down, this feature right here slows down the shortwave and better interaction. So that's the theme of our weather pattern. Okay, so that way you understand that each model run, you might be very happy in some, wherever you might live, with the 12Z model guidance right now. Do not be surprised if you see flips and flops of the 0Z guidance to a warmer solution, a significantly colder solution, and all that is driven not by model trends or some magic globe or anything like that. The reason why you're seeing that is because it comes down to the interaction of these individual shortwaves, which we can see right here in the water vapor satellite picture, currently out in the Pacific, that influence this weather pattern. And so, as a result, every model run you see is a different depiction of how those shortwaves interact. So that's what you're seeing, this quote-unquote windshield wiper effect. As for the next 90 hours, heads up for those of you in the Poconos and Catskills. Let me zoom in here. Here we are. Okay. For tomorrow morning, with the initial precipitation coming in, I'm concerned in northeastern Pennsylvania, and especially in the Catskills here, of this precipitation starting off as snow, sleet, and freezing rain, maybe even a little bit for Sussex County. Right now, the boundary layer temperatures are not all that impressive, but they're expected to fall. And you have just enough marginal cold air showing up at 850 millibars with enough mixing that I'd be worried about a little bit of slick roadways up there. So just putting that out there, just use caution. Everyone else is just rain, not that big of a deal. We could see about an inch of rain, so definitely you're going to have your umbrella for tomorrow. And then our next storm, like I said, we'll be keeping an eye on that evolution. If you want to make a case for a colder solution, what you'd want to see, and let me stop jumping here. Here we are. Okay. What you want to see is, you see this trough right here? You want a little bit more neutral. And you want this shortwave out here to be right about here and interacting with this trough. And because of that little shift, you want this 850 millibar low that is showing up right here. See that little signature right here? You want that signature to be out here. So you need a shift of about 50 miles. Right now, I don't really see any support for that. But if you're looking for that, those are the factors that you would need to look for. A more neutral trough at 500 millibars, and this short wave out here in the subtropical jet stream a little bit further east, not by much, but just a little bit, because then that leads to your 850 millibar low forming here rather than here. If it sets up like this, forget about it. It's rain. Maybe a little bit of snow at the very start, but I doubt it. And so that is what causes that solution. Pretty impressive snowfall here in the Poconos and Catskills for this event, Sunday night and a Monday. And the reason why you're seeing that, there we go, is because in this scenario, when you have your 850 millibar low like this, strong lifting, at 700 millibars, your 700 millibar low is starting to form. Very impressive lifting here. The old one's decaying back here. So you get stretching in the atmosphere. And also very strong frontogenesis out here. This type of environment produces probably about a 10-to-1 ratio in snowfall. So it's going to be like a heavy wet cement type snowfall. But certainly we don't know what the exact accumulations will be. But in this setup, this would lead to a very heavy wet snow for the Poconos, Catskills, parts of the Hudson River Valley. Even the western suburbs of Philadelphia would be in game for this. But because of the development of 850 millibar low, those of you around the I-95 corridor and towards the coast, you maybe see a few flakes at the beginning and the end, but this is pretty much rain. So that pretty much touches everything. I really don't want to dive into the next storm until we get this first storm done with. But I will say that if anyone thinks that this is the shot and that's it, there's a lot more Arctic air to work with. And this is all happening during the stretching of the polar vortex and not with the complete disruption and significant stratospheric warming event that might be possible by the time we get to this time period in the stratosphere, which would mean that all of February and early March would have very high potential for a lot more cold air and a lot more potential for winter storms. So if you're looking for early spring out of this, if that stratospheric warming actually pans out and it's getting a lot of support, then you could kiss an early spring goodbye. I could tell you that right now. So now with all that, we are going to dive into answering some questions. Of course, we're going to start with the stratospheric environment first, and then we will go to YouTube as well and take the best questions out of there. So looks like we have a lot of questions, so we're going to be pretty busy this evening answering all of this. So let's get to this. And we got the data up there. Good. Okay. So let's scroll all the way back up here to this is from Joshua. What's Cleveland looking like for this pattern change? Well, let me put it this way. If the northern Atlantic is setting up for a major pattern change, obviously Cleveland would be. The storm tracks will likely be to the east of you, but I keep an eye out on that lake effect snow impacts, that is for sure. Also, is the volcano from last year still having an effect? Yeah, that volcano from last year is going to be impacting the stratosphere, especially with the influence of the water vapor, for the next several years. That's not going away anytime soon. The ozone buildup looks like it is more than the ones we had in the winters in the past, a couple of years ago when solar activity was lower. I think that's because of that influence from the volcano altering the EP flux. That's my theory. I don't have enough data to say for certain, but that's what I'm theorizing. And that's why I think we're seeing that ozone buildup. Are you concerned that some models that you rely on may be giving a false positive for a sustained pattern change? That's an interesting question. Okay, so let's play devil's advocate. Let's say that the first storm that's moving through on Sunday night and Monday is significantly warmer, and the storm track cuts up towards, I don't know, White Plains, and you get a rain-snow mix over the interior. So that first short wave lifts into the northern Atlantic and doesn't produce the high latitude blocking that we're looking for. So let's say, where are we? Okay, let's say this feature is much weaker, and as a result, the blocking that results from it, which would be this, is much weaker and nowhere near as impressive. And so as a result, this feature is able to cut up towards the Great Lakes. That could happen, which would allow for this Arctic air mass and this polar vortex in the troposphere to drop towards the Rockies and build a ridge on the East Coast. That could be a unlikely but possible result. That would be a scenario in which the model guidance was completely off on the development of this storm that is 5 days out, so much so that the storm track is 150, 200 miles off to the west. Could that possibly happen? Well, what you would have is a scenario like what we saw in December, but far more dynamic. And right now we don't really see any hints of that. In fact, we're seeing more hints of a colder solution than a warmer solution, although I'm not ready to trust on that just yet. But that's what you would have to set up in order for there to be a false positive in this pattern change. The reason why I would have doubts on that is because such a forcing parameter to cause that would have to rely on a strong La Nina. And we know that La Nina is weakening. So I don't think that is a solution that would develop. But that's a great question. Let's see. Snowball says 6 weeks of winter into coming. Yeah, well, we'll definitely see. Had some appropriate music for the Metal Chaos on just before logging in. Whiplash by Metallica. Yeah, that would do it. When is the time period when the first real chance for snow is realistic? Well, that kind of depends on where you're located at. For the interior, I would say Sunday night, starting Sunday night. For a coastal plain, well, look, if everything works out with this storm on Sunday night and the Monday, then you certainly have a much better potential for snowfall setting up for the middle of next week. So those of you on the coastal plain, again, don't trust the details just yet because this shift's 25 miles and this is all snow here. Those of you around the I-95 corridor, it looks like the middle of next week, actually right ahead of our next live chat, would have a pretty good potential for some significant snowfall. We'll see how that works out. The ozone buildup looks like it is more than the ones we had in the winters of the past. Yeah, possibly. Let's see here. Rob Allen says, figured you would be interested to know a certain individual who felt the need to talk in December just completely called himself out that he is going to be wrong about the rest of winter due to the observations. Thought that might make you smile. You know, any meteorologist that has an idea and they just end up wrong, I just hope that they take that opportunity, as I have when I have busted, and God knows I have and I will in the future, takes that opportunity to learn from what they have experienced and become a better forecaster in the end. Because that's really what we all should do. We all are going to have bad forecast ideas because you're trying to figure out chaos. And the best thing to do is to learn from that chaos, take it in, and become stronger and better. Is this the kind of situation where if one storm phases in a way so that we have a storm that gives us snow down to I-95 corridor, does that first storm enable the pattern to lock in the following storms toward the opposite of December? Yes, exactly. Exactly. One storm feeds into the other, into the other, into the other, and boom, before you know it, you got a whole seasonal forecast and people saying, no more, I'm ready for spring and baseball. Is that possible? It's close. I am not ready to say that that is going to happen. But boy, oh boy, if there was a pattern to set up that potential, it's very, very close. However, understand that if one little thing is off by just a little bit, we miss our potential. Okay? So let's just be very clear. I don't want anyone saying, Stephen promised me 10 feet of snow in my backyard. I'm not saying that. What I'm saying is that this setup is there to produce some very wintry potential here. Also, if La Nina's remnant high, Atlantic high is displaced eastward, which it looks like it is right now, could that serve to help blocking by keeping the southern short waves from sliding out to sea? Okay, that's a great question. Okay, so let me show you how that works here. And we'll use the operational guidance in this respect. And let's go right here. Okay. So here is a scenario right here. Here's our southeast ridge that gets displaced, right? So obviously you can't have, your heights building into the southeast. So it's really unlikely to get like a storm forming out here and lifting up the coast. But here's your shortwave here. Here's your ridge here. And here's this trough here. Remember, the atmosphere is always trying to balance itself. Okay, that's the whole reason why we get storms. It's a process of balancing out different features in the atmosphere, whether that's temperatures, i.e. heat, or the expansion of heights, or the contraction of heights. There's always a balance, all right, to zero everything out. This ridge here, because it's displaced, has an influence on this trough here. Because these two are trying to cancel each other out in terms of influence in the atmosphere overall. So if this trough intensifies, this ridge intensifies. This ridge intensifies, leads to this trough intensifying, tit for tat. That feedback leads to this feature not able to cut up towards the Great Lakes, but forced somewhere around here. But it's not able to dig down here because this ridge is getting stronger. So it's working. All these features are interacting and working against each other. So that is how, because that's why this feature is so important. Because this feature forces this feature to strengthen, which in turn forces this feature to strengthen, which in turn forces this feature to slow down, this feature to interact with this feature, and those features leads to a main attraction and a feature snowfall. See? You see how that all interacts? Now, if this is off by just a little bit, or this is off by just a little bit, that whole process gets short-circuited, and this trough ends up being weaker, the block collapses, and this cuts up towards the Great Lakes. So it's a very delicate balance, but you could see how that feedback process all plays out. We're now in the fourth longest snow-free stretch in New York City history. Very true. I'm old enough to remember those much snow-free winters in the early 1970s. That's true too. What would an El Nino mean for spring and summer weather? I am not sure yet, and the reason why I'm not sure yet is because I am still trying to figure out what the intensity would be, the orientation, But typically, El Ninos, when they start, and this would probably be more towards the summer, leads to a lot more short waves coming in from the subtropical jet stream, a lot more shear in the Atlantic, so you reduce your tropical Atlantic activity. More severe weather possible towards the plains and in Tennessee River Valley, so the tornado season might be rather interesting. The East Coast at times can end up with cooler than normal summers. But again, that all depends on orientation of the actual El Nino that develops, how strong it gets, and how long it takes to develop. So a lot of unknowns there. Is there any truth to rumors that the southeast ridge is going to flex its muscles and ruin winter from mid-February on? Okay, so if we don't get this major disruption in the polar vortex, it's just a stretch, right? Typically, stretches last anywhere between 2 to 3 weeks, and then they contract. So if you have the polar vortex contracting and strengthening around mid-February, that would allow influences of La Nina to come back and cause a warmer pattern, kind of like what we saw from what we've been in, right? But if you have the major disruption and the strong stratospheric warming, that would negate the La Nina influence and basically kill any potential of a southeast ridge, leading to a warm late February. But a lot of that is still, all cards are on the table. I can't say no, but we also know if that stratospheric warming event actually takes place, that really hurts the chances of an early spring. Because typically when that evolves, late February is cold, active, possibly snowy. Same thing for early March, and then it gives way around March 15th or so, and then we move into our spring pattern. So, is it possible? Yes, but it would only be possible if the forecast that we're starting to see with the polar vortex doesn't verify. La Nina, other than the occasional southeast ridge, was never particularly strong except for the brief moments. Was more like an El Nino the last year. Yeah, it's been an unusual La Nina to say the least. It's way out there, but the Euro 10 days out has some bitter cold in northern mid-Atlantic, single-digit temperatures. Yep, there's certainly a hint of that. I'm kind of staying away from that now because a lot of that depends on the evolution of our third storm in this pattern. First storm's coming through tonight. Second storm comes through Sunday night and Monday. Third storm is the one with mostly snow for many locations aside from southern New Jersey. So there's a lot to work out there. 10 millibars already stretched pretty good, and 70 millibars as well, looking at Earth New School. Let's pull that up real fast. Now remember, the past couple of weeks, we have been seeing this polar vortex. Let's zoom out here. Oh yeah, oh hello stretch. Well, as we have known for the past couple of weeks, this polar vortex has been looking more like a donut than anything else. Now it looks like someone's really crushing the two sides here. These are higher pressure regions, and it's stretching and pulling on that polar vortex. And you can see that at 70 millibars. You see, this is where it gets really cool. You see how it's kind of getting wiggly here? It's not like tight and concentric. This feature at 70 millibars, what this means is that cold air that is built up here in Siberia is able to advance southward. You don't lock everything up in the Arctic like a freezer. Now the freezer door is open. Let the colder air begin. And how much colder air? Well, let's go down to the surface, pull up temperatures. And ladies and gentlemen, that is some very impressive cold air here in Siberia. You get a cross-polar flow like what's being suggested in some of our model guidance here, like this feature here, and this feature right here. You get that type of setup with that type of cold air that is heading our way towards North America. Let's see here. Are you buying the depiction of a negative NAO, and what are your thoughts on the alignment? Well, we talked about that already. I think it's certainly potential out there. I like the idea of it. if that storm develops as what's being forecasted 5 days out, I think that we have a pretty strong case for a weak to moderate west-based negative NAO pattern starting to develop. And if that happens, let the fun begin. Now let's check out here. Let's see. Now I'm going to take the best questions. Let's see. What trends in modeling should we look for a better chance of snow for the Mid-Atlantic? We should look for interactions in which the high latitude blocking.
I think we have a connection problem because it says you're live, but you stopped.
Uh-oh. Are we all right?
I don't know what's going on.
Is it a YouTube thing?
I don't know
Or
if it's a connection issue or what. Here we go again.
we're back? Oh, good. All right. Hey, we're back. Okay. Sorry about that, guys. All right. So let's see here. Go back to, I'm answering the YouTube questions now. And one of the questions I have, what trending should we look for a better chance of snow for the Mid-Atlantic? Okay. So I'm going to give you this in general. Okay. What you want to look for is for, and let me jump to this here. Yeah, here we are. Okay. So what you want in this scenario is you want to see your 500 millibar heights crash like this in kind of like a negative tilt. So you kind of see this signal right here. You also want to see this feature, this 850 millibar low feature, focus more towards the coastal plain. Because if that happens, then all your cold air gets trapped in the coastal plain and you end up with a snowfall event. So you want to have your upper level low features focused towards the coastal plain. Let's see here. Let's see here. Good evening, Steve. Is there any chance of rumble or thunder tomorrow evening? There could be a potential for some embedded thunderstorms, but nothing too strong. Let's see here. What would you expect in a transition to end zone neutral conditions? Typically what I see is a equally balanced polar jet stream and subtropical jet stream. Typically a pattern that features some more potential for high latitude blocking, but a very fast moving weather pattern as well. On the Strat Observations website, there is a chart for wave 1 heights and wave 2 heights. What exactly is wave 1 and wave 2 in terms of the polar vortex? Well, that's a great question, but a very long answer. What I would say is that, how do I explain this in layman terms without, I want to be really careful because it's a very technical, but basically what you're looking at are ways in which the atmosphere is interacting from the troposphere to the stratosphere. And those waves are part of what we call Rossby waves. And that reflection leads to a transport of heat from the mid-latitude, from the troposphere to the stratosphere that can disrupt a polar vortex. And so the stronger the waves are, the stronger the disruption. And so that gives you an idea of the potential for major stratospheric warming events. Is central New Jersey getting any snow? No, I don't think this first storm, Sunday night and Monday, but the second storm has better potential, but we'll be keeping an eye on it. Do you think Wednesday, Thursday could be a major snowstorm? Don't know yet, as we've discussed. Do a session into mouse settings, increase your mouse to extra large. You know, I tried that in another one and it almost crashed the system for some reason, but I'll take a look at it. Could model guidance change abruptly based on the track of this upcoming system? A lot would have to change. I don't want to say no because there's a lot going on in this weather pattern, but it would have to be something that would be pretty dynamic, because now we're getting into that 5-day range. It's no longer like a 10 days out, 7 days out. But what would have to change is the speed of that polar shortwave. And that change could be warmer if that phase happens too early. So be careful what you ask for. But that is some great questions. Let me check out YouTube here. We got more questions here and on the premium site here at 10 millibars. The most noticeable feature that I don't recall is the two highs. Yeah, that is part of the process of the disruption. Those two high features, which let me go back to winds, 10 millibars. Okay, these features here are the indication of heights building from the troposphere into the stratosphere and that stretching that's occurring. Okay, is back after I refresh. Okay, good. Based on historical snowfall data for Philadelphia dating back to 1884, that's a long time, the current 5-year average for annual snowfall is 10.8 inches, is the second lowest on record. You have to go back to 1931-32 to see a less snowy period than what we've experienced. So it'll be interesting to see the potential is actually realized. You know, it's interesting when we look at that data. There's a lot of factors that we have to consider when we study that data. The urban heat island effect, for one, the influence of some climate change, obviously, and also the way that our weather pattern has been evolving, influences from volcanoes. There's a lot of stuff to consider in that data, but we're certainly. Well, look, I know that some of you guys are definitely snow-starved. I understand that. I see your long-range thoughts is about solar activity. You always have that Thursday night. Why the change? I'm just going to be a little bit busy, so I decided to do it tonight. I might not be able to do it tomorrow, so I figure I'd just do it tonight. That's why. I know some people don't like it when I do some changes, but sometimes it's good to mix things up. Let's see here, and I think that is it for the questions. There's pretty good questions here tonight, guys. Okay, so now I think we've kind of gone over everything. With this potential storm, we certainly have that potential here for wintry weather to return. The first storm on Sunday night into Monday is going to be the key factor in what is going to be driving the next couple of storms after that. Not so much the solution as far as like rain on the coast or snow over the interior or anything like that, but this part right here. If this feature forms that upper level low lifting up into the Canadian Maritimes, that sets up the blocking for all the other storms. And then you could start discussing a realistic potential for a feedback pattern. So the storm on Sunday night into Monday, I'm not so much concerned as to whether or not the coastal plain sees snow as far in terms of the forecast. But what I want to watch out for is whether at 140 hours, and let's go back to here, that this feature actually develops. Because if this feature develops, that sets the stage for everything else. And I got one more here. Okay. Is that Don Sutherland with the comment? Only guy I know who have that historical weather data. Okay, all right. So, will ocean temperatures decrease as a result of these next couple of storms? Not significantly. Typically, what you'd look for ocean temperatures in the Atlantic to significantly cool is the introduction of Arctic air, sustained Arctic air. I don't really see that happening. But what I do see is with the current water temperatures and the introduction of polar air is the potential for rapidly intensifying cyclogenesis because of that thermal gradient, enhancing frontogenesis on the coastal plain, leading to more dynamic storms. There's this idea floating around I don't know where it came from, but this idea that the warm water off the East Coast leads to more rainstorms, that is wrong. The reason why we have such dynamic winter storms is because of the Gulf Stream and because of the warm water. As long as you have winds coming in from the northeast and northeast in a winter storm, the water temperatures off the East Coast really don't have too much of an impact in limiting snowfall potential during this time of year. Different story in November and December where your water temperatures are just naturally too warm. But in this scenario, with where the water temperatures are right now, it's not so much of a factor because you have stronger polar air masses to work with to override that influence. Are you surprised that the NHC did not name the Atlantic storm as a subtropical storm? A bit. I don't know what happened there. It's interesting. It certainly looked subtropical to me. You know me, I don't like jumping the gun on those type of scenarios, but it sure looked tropical to me. Convection right around a low-level center, circular convection, no sign of any frontal interaction within that low-pressure system. It looked like textbook subtropical storm to me, but they didn't name it. It is what it is. Moving on. So let's see here. Georgia folks, okay. Yeah, I guess so. Yeah. In the polar vortex, what is the difference between wave 1 and wave 2? Oh man, that is a very technical discussion. Let's see, how do I put that in a very short period of time? I tell you what, I think what I'll do is maybe that will be my long range thoughts for tomorrow on explaining wave 1 and wave 2, because that is a very long discussion to have. But basically, it is the lifting parameters involved in that disruption. So I'll definitely talk about it in the long range thoughts. I guess they don't want another above average season. I don't know. I'm not going to make any guesses on that. So I think that's it for tonight. It is pretty much 9 o'clock. We've definitely talked a lot about this potential. We have a high threat next week at this time that we're talking about and watching snow invading the region. The reason why I'm being very hesitant here is that I understand how much this can all change very quickly. The disruption of the polar vortex opens up a high threat for winter cold to return and snow to return. There's no doubt about that. But we also have to recognize that this has been a very unique and unusual weather pattern this year, considering the lifting parameters we have been observing. And I have been hesitant in being gung-ho about these snow solutions because I want you to understand of how delicate this process is. And if we don't understand that, then it leads to a lot of emotional overreaction to every model run that comes out. I don't want you doing that. So, what I would say is this. Be prepared for winter storm impacts. Make sure you have your snow shovels, your salt, whatnot, okay? But don't jump the gun, and certainly do not trust any snowfall forecasts until we start getting under 120 hours, heck, even 90 hours, to really establish what our potential is with each storm. Because I fully expect, as this pattern evolves, and as all these changes are happening in the atmosphere, to continue to see model guides produce high volatility in a wide variety of solutions. So with that tonight, what I will say to you is that potential is high, the pattern's active, the cold air is going to be available, Now we see whether or not it all comes into fruition and produces winter storms or a lot of near misses. And that is the theme for tonight. So I just want to thank everyone for joining and following along tonight, and a lot of great questions. And thank you again. And as always, stay safe out there.